Hello friends, welcome to Learner's Planet. Friends, this is our first session for the topic averages. Though the topic is very simple, but there's a huge demand of the students to go for this topic, so I'm just going to discuss this one. Though we have already discussed the basics of averages in our various calculation sessions, we have already discussed the topic alligation and make sure that is precisely similar to averages. Okay, so in this session I'll be just taking the basic concept and basic problems based on averages, though the topic is itself a basic topic. Okay, so let's begin the session. Basically, average is arithmetic mean. Average is arithmetic right, and it is sum of observations by number of observations. Right? Suppose you have to find out the average of say first 10 natural numbers, right? The first 10 natural numbers is 1, 2, 3 till 10, right? If you have to find out the average of these 10 data, that means you have 10 data. So number of observation is what? 10. Now sum of these 10 numbers will be what? Sum of first n natural number is given by n plus 1 by 2. So sum of first 10 natural numbers will be 10 into 11, that is n is equal to 10. So 10 into 11 by 2. Right? So sum of first 10 numbers is 55. Number of observations is 10. So average is 5.5. Right? So what is average? Sum of observations by number of observations. Okay, or you can say sum of numbers by number of numbers. Friends, apart from arithmetic mean, there is geometric mean and harmonic mean also, right? But details or detailed concepts and problems based on arithmetic mean, geometric mean and harmonic mean we'll discuss in our progression and series sessions. Okay. So here in this particular topic average, I'll be just discussing the arithmetic mean, and that is the average, and average is sum of observations by number of observations. Okay, so let's take the first problem. Here David obtained 76. This is this marks in English. What were his average marks? See, average is nothing but the sum of observations by number of observations. To make the problem simple, what you can do is you can assume an average and you can see the deviation, right? From options I just can see that's the average should be around 70. So I assume the average to be 70. Just listen to me carefully so you can reduce the calculations to certain extent, right? I am assuming the average to be 70. Now I see the deviation from 70, maybe positive, maybe negative, right? So this is plus 6, this is minus 5, this is plus 12, this is minus 3, and this is plus 15, right? Now this is the deviation from 70. If we divide this by 5, we will be getting average deviation. Now if the average deviation is positive, then you have to add the deviation to it. So you'll be getting the exact average, and if it is negative, then you have to deduct the same from it. Then you'll be getting the exact average. Okay. So now quickly calculate it. It is minus 5 minus 3, that is minus 8 plus 12, that's plus 4. 6 plus 4, 10 plus 15, 25 by 5, it's 5, and that too positive, right? So since the deviation is positive, we'll add this to it. So average is 75, right? After some practice, you don't have to write the assumed average over here. You just keep that in your mind. Okay? I hope you are getting it. Now this question, in Arjun's opinion, his weight is greater than 65 but less than 72. His brother does not agree with Arun. He thinks that Arun's weight is greater than 60 but less than 70. His mother's view is that his weight cannot be greater than 68. If all of them are correct in their estimation, what is the average of different probable weights of Arun? Okay, so that's pretty simple. We have to find out the number of weights where Arun is where that particular observation is fulfilling all the three conditions, that is between 65 to 72, between 60 to 70, and not more than 68, right? So 65 to 72, then between 60 to 70, 60 to 70, then less than 68. So precisely 65, 66, 67, 68. These are the four data, four different probable weights of Arun. Now we have to find out the average of these four. Now these are the four consecutive numbers, so average will lie somewhere between these two numbers. So exactly between these two it is 66.5. Okay. So that's none of these over here. Now one important thing over here is see, we are taking the weight of Arun to be an integral value, right? But it is not mentioned over here that the weight of the Arun is an integral value. So that's an assumption over here which I am taking. Okay, but in exams there should be mentioned, because this seems to be an incomplete question. Unless until it is mentioned that the weight of Arun is an integral value, you cannot take all the values to be integral, right? The average of 20 numbers is 0. Of them, at the most, how many may be greater than a 0? So it's a simple question. Average is 0, right? Now we have to find out at the most how many may be greater than a 0. See, at most maximum numbers are 19 over here, right? And 19 value at most can be greater than 0. For example, suppose I take maybe, see, we are taking the positive values this side and negative values this side, right? Suppose all these positive values sum up to 20, right? And there is a single negative value that is minus 20, right? So one number less than 0, that is minus 20, and 19 number more than 0 where their sum is 20. So that's practically possible. So if you take average of these 20 numbers, you'll be getting the average as 0, right? So it is possible at max 19 numbers can be greater than 0. All 20 numbers cannot be greater than 0. If it is the situation, you will not be able to get the average to be 0. So that's just one number less than 0, that is minus 20. All remaining numbers are positive numbers, that means more than 0, and their sum is 20. So this is a situation possible. Okay, just a logical thinking based question, nothing to do with deep mathematics. Find the average of all the numbers between 6 and 34 which are divisible by 5. Very, very simple question. The first number that is divisible by 5 between 6 and 34 is 10, and the last number is 30. So that's 10, 15, 20, 25, 30. Okay, so average must be 20, obviously. Now let's see this problem. A student was asked to find the arithmetic mean of numbers this. He found the mean to be 12. What should be the number in place of x? So in all there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 numbers, and their average is 12. That means sum by 12 is equal to 12. That means sum should be 144, right? So all these data should add to 144. Okay, so quickly do the sum, so we'll be able to get the value of x. So precisely it is 7 and 3, 10, and 20, 20 and 10, 30. 45, 58, 66, 66 plus 40, 106, 106 plus 17, 23, 23 plus 14, 37. So we are left with just 7. So the value of x must be 7. Okay. I hope that's clear to you. Now this question can be done mentally. The average of 2, 7, 6 and x is 5. That means 2 plus 7 plus 6 plus x, that is sum of these 4 observation should be 4 into 5, 20. Right? So value of x can be calculated easily. 7 plus 6, 13, 13 plus 2, 15. So 15 plus x is 20, that means x is 5. Right? So we got the value of x. Now 18 plus 1 plus 6 plus 5 plus y is 10. So 1, 2, 3, 4, 5. Sum of these 5 observations must be 50. Right? Sum by number of observations is equal to 10. So sum must be 50. So 18, 19 and 6, 24, 24. I'm sorry, 19 and 6, 25. 25 plus 5, 30. 30 plus 20 is 50. Okay, so the value of y will be 20. I hope it's clear to you. Now this question, even this question can be done mentally. If the mean of 5 observations x, x plus 2, x plus 4, x plus 6, x plus 8 is 11, then the mean of the last 3 observation is. Now you can see these 1, 2, 3, 4. These 5 are consecutive. You can say even number or maybe odd numbers. Okay. Or we can say these 5 numbers are in arithmetic progression. The common difference between the consecutive number is same, right? So the mean will be definitely the center data, or we can say the middle data, right? So x plus 4 is actually the mean of all these 5 data, 1, 2, 3, 4 and 5. Now mean is given to us as 11. That means x plus 4 is actually 11. That means x has to be 7. Right? Now we have been asked the mean of the last 3 observation. Last 3 observation 1, 2, 3. Right? Again the 3 consecutive either even numbers or odd numbers. So or we can say the 3 are in arithmetic progression. So the mean of x plus 4, x plus 6 and x plus 8 will be x plus 6. Right? Now we know x, that is 7. So actual mean will be 7 plus 6, that is 13. Right? So just a very simple conceptual problem. You don't have to go for much paperwork in this case. Okay. Now if the mean of ABC is m and AB plus BC plus CA is 0, then the mean of this is. Now the problem seems to be simple. You just must be knowing the formula for A plus B plus C whole square, because in that particular formula only we get this and this. Right? So A plus B plus C whole square is equal to A square plus B square plus C square plus 2 AB plus BC plus CA. Right? Now mean of A, B and C is m. That means A plus B plus C by 3 is m. That means A plus B plus C is 3m. Right? Now we have to find out A square plus B square plus C square, and this thing is given to be 0, so it is 0. Right? So A square plus B square plus C square is equal to 9m square. Right? But we want the mean of A square, B square and C square. That will be A square plus B square plus C square by 3. So A square plus B square plus C square is 9m square. So if I do it by 3, I'll be getting 3m square. Right? So pretty simple. Now this question, the average of the 2-digit numbers which remain the same when the digits interchange their position. So obviously the numbers are from 11, 22, 33 till 99. Right? So start from 1 till 9. We don't have to count. There will be 9 numbers. Right? So the difference between the consecutive numbers is 11. Right? So that's an arithmetic progression. So average of this all 9 data will be nothing but the 5th data. Right? 1, 2, 3, 4 this side, 4 data this side, 4 data this side, and the 5th data will be average. So that is actually 55. Okay, no need to calculate. Simple funda we are using over here. If the numbers are in arithmetic progression, then the middle number will be their arithmetic mean. Okay, now this question, the mean of these data. Okay, so you have two options. Either you can use the direct formula of sum of first squares of first 7 numbers, right? So that's sigma n square is n plus 1 2n plus 1 by 6. That will be sum, right? So here n is equal to 7 because there are 7 numbers 1 2 3 4 5 6 7. So that is 7 into 8, 7 2s are 14 plus 1 15 by 6. That is sum of all these numbers. Now there are 7 numbers. If I divide it by 7, I'll be getting the average. Okay. So that's 20. As simple as that. Okay. And suppose the data are not in any particular order, so what you can do is you can go by the deviation method as well, right? What I do is, for simplicity, I assume the average to be 20 and now I see the deviation. So it's 1, so precisely it is minus 19, it is 4, so it is minus 15, it is 9, so it is minus 11, it is minus 4, it is plus 5, then plus 16, and plus 7 square is 49, so plus 29. Okay, I'm sorry, actually this is minus 16, right? So we just cancel that out. Minus 16 plus 16, then 11 and 4 minus 15, and this is plus 5, so precisely it is minus 10, minus 19 minus 10, it's minus 29 plus 29, 0. Okay, so we assume the mean to be 20 and the deviation is 0, so actual mean is 20. So you can go either way. Now this question, if A, B, C, D, E are 5 consecutive odd numbers, then their averages. See again, if these 5 numbers are 5 consecutive odd numbers, that means they are in arithmetic progression, right? If the numbers are in arithmetic progression, then the middle number is the arithmetic mean, or we can say average, right? So here average is C. Okay, so we don't see any option among options as C, so it's none of these. No paperwork is required at all, right? Now see this, the average of a non-zero number and its square is 5 times a number. So average of non-zero number and its square is equal to 5 times the number. I assume the number to be x, then average of x and x square will be x plus x square by 2, and that is actually 5 times the number, so that's 5x. So precisely x square is equal to 10x minus x, that is 9x. X should not be equal to 0. I take x as common, so precisely x will be 9. Okay. Now the average of 7 consecutive numbers is 20, the largest of these numbers. Again, it's a very simple problem. If there are 7 consecutive numbers, that means the average will be the 4th number, that is the middle number. So A, B, C, D, E, F, G, right? These are the 7 numbers. So this will be the average, right? Now since an average is given to us as 20. Now since there are these are the consecutive number and D is 20, that means it is the largest number must be G, so that is 21, 22, 23, right? If you are conceptually clear, no paperwork is required at all. I hope you are getting it. The average of 5 consecutive odd numbers is 61. What is the difference between the highest and lowest number? Now again, 5 consecutive odd numbers may be A, B, C, D, E, and this one is 61. Again, because these are 5 consecutive odd numbers, so the middle number will be the average. Okay, so this is 61. Now these are 5 consecutive numbers, so this number must be plus 2 and this must be plus 4. This will be minus 2 and this will be minus 4, right? So difference between the highest and lowest number is plus 4 minus 4, that's 8. Okay. The sum of three consecutive odd numbers is 38 more than the average of these numbers. What is the first of these numbers? Sum of three consecutive odd numbers, I assume the numbers to be a plus 2 and a plus 4, right? So the sum of three consecutive numbers is this, and it is 38 more than their average. So that is a plus 2 plus a plus 4 by 3. That's the average, and it is plus 38. Okay, so we have to find out the first of these three numbers. I assume this entire quantity to be x. Okay, so precisely it is x minus x by 3 is 38. So 2x by 3 is 38. So x is equal to 57. That means sum of these three numbers is 57. Now first will be, so sum of these three consecutive odd numbers is 57. So average will be 57 by 3, that is 19, and this number will be average, and this number will be 2 less than this. So it is 17. So the smallest number, or the first number we can say is 17. Okay, so that's pretty simple. Now, the average annual income of certain agricultural workers is S, and that of other workers is T. The number of agricultural workers is 11 times that of other workers. What is the average monthly income of all the workers? So there are two ways. Either you can assume the values of S and T and proceed, or other way is I just explain both the methods. The average is S. I assume the total number of agricultural workers is S. So the total annual income of agricultural workers is SX, right? And the number of agricultural workers is 11 times that of the other workers. So if agricultural workers are X, then the other workers are X by 11, right? And these are the non-agricultural workers, and their average is T. So the total is this. So total of all this, that is agricultural plus non-agricultural, will be Sx plus X by 11 into T, right? These are the total annual income of all the workers. Now how many workers are there? Agricultural workers X, and non-agricultural workers X by 11. So these are the total number of workers, right? So that's simple. So what you can do is you can take X as common. So that is, or after that you can just take LCM. So it is 11S plus T upon 11 plus 1, 12. Okay, so that's pretty simple. Or what you can do is you can assume the value of S and T. I assume S to be 5 and T to be, say, maybe 8, right? Now a number of workers, for other workers I assume maybe 1, then the agriculture workers will be 11. So the total income of all the workers of agriculture will be 11 into 5, 55, and here it is 8, right? And the total divided by, that's 11 plus 1, 12. Okay, so that is 55 plus 8 by 12. So if you match, you'll be getting 11S plus T by 12. Okay, don't calculate actually, but you can match it easily. Okay, now we see this problem. A family consists of grandparents, parents and 3 grandchildren. The average age of the grandparents is 67 years, that of parents is 35 years, and that of grandchildren is 6 years. What is the average age of the family? So what you can do is, there are again two methods. What you can do, simply you just add up all the data. 2 grandparents, so 67 into 2, 2 parents, 35 into 2, and 3 children. So 67 into 2 plus 35 into 2 plus 6 into 3 divided by 3, 4, 5, 6, 7. That will give you the average age of the family. And apart from that, if you don't want to get into the big calculation, what you can do is you can just assume the average and proceed accordingly, right? See the deviation and proceed. Okay, so what I do is looking at the option, I assume the average to be 30. Now I see the deviation. So 67, 30, difference is 37 for 2 persons, so it's 74. 35 into 2, deviation is 5 each, so in all it is 10, and deviation here it is minus 24, that is a negative deviation, so minus 24 for 3, so that comes to minus 72, and in all there are 7 persons, so this is the average deviation. So 74 minus 72 is 2 plus 10, 12 by 7, so it's 1 plus 5 by 7, right? So 30 was the initial average or assumed average. 30 plus 1 plus 5 by 7, that is 31, 5 by 7. Okay, 30 plus 1, 31 plus 5 by 7, so that is equivalent to 31, 5 by 7. Okay, so this way you can save your time if you just go by the deviation method. Now this problem, a library has an average of 510 visitors on Sundays and 240 on other days. The average number of visitors per day in a month of 30 days beginning with a Sunday. Okay, if the month is beginning with Sunday, the first day is Sunday and second day is Monday. For remaining 28 days, each day will come for 4 times, right? 4 Sundays, 4 Mondays, 4 Tuesday, Wednesday, Thursday, Friday, Saturday. So precisely Sunday and Monday will be 5 times, right? There will be 5 Sundays and 5 Mondays, and the remaining days will be 4 each. 4 Tuesday, 4 Wednesday, 4 Thursday, and something like that. Okay? So we have to find out the average of number of visitors per day in this month. So precisely your calculation is for 5 Sunday, total number of visitors is 510 into 5. For 5 Mondays, it's 240 into 5. And for each other day, that is 20 days, each day 240. Or what you can say is 5 Mondays and remaining 20 days, in all 25 days, each day 240 visitors are there, right? And this divided by 30, that is your calculation. Okay, so you can take this off. So 240 into 25 plus 5 into 510 by 30. So instead of multiplying these and adding these, what you can do is just go for the individual calculation. 510 into 5 by 30, 0 and 0, and that's 17, so it's 85, plus 240 into 35 by 30, so 38, so 25 plus 8 is 200, so the average is 200 plus 85, 285. Okay, and again you can go by the deviation method. I assume the average to be 300, so I see the deviation of 5 Sundays, each is 210, so 210 into 5 is 1050, and deviation of other 25 days is 60 each, right? 300 and 240, 60 each, so 60 into 25, so it's minus 1500. And if we divide this by 30, we'll be getting the average deviation. So precisely it is 450, so it is minus 15. This is minus 450, so the deviation is minus 15, so the average will be 300 minus 15, that is 285. So deviation method is really useful to save the time. Okay, so friends, we will be taking more problems based on averages in our next session. Do revise this session, and let's see what happens in the next session. Bye bye.